Welcome, everybody, to the final session of our 2020 Virtual Conference in Science Education, brought to you by the Nebraska Association of Teachers of Science. My name is Scott King. I am the president-elect of NATS, and I am absolutely thrilled to present Kathy Renfrew today as our final speaker. She'll be talking to you in a moment about phenomenon and what we can do, or we can use it right now to move students forward. And Kathy has made a request. You guys have pencil and a paper for this session, something you can write with, some notes or brainstorming ideas. Please, if you guys would, after your name, put in your grade level and your state, just to help our speaker know kind of where you're coming from and how to tailor answers to fit your needs. The microphones, if you guys would keep your microphones muted, it helps prevent some of the feedback issues that we might be experiencing. Also, if you're having any bandwidth issues, consider turning off your camera, though you're more than welcome to keep your camera on. It gives our guest speakers something to look at, and we can look at all your beautiful shiny faces. We do have a couple of norms we're going to follow today, which is we recognize that you are here voluntarily for the good of your students, and that is an amazing thing for all of our guests that we have today. And we want to remember that everybody else here is trying to do the best for their students as well. Everybody's ideas are important and valid. And if you guys have a question or if you have something to share, we will recognize that. But please do so in our chat, in any of the additional links and things that our speaker will be presenting with, or by unmuting yourself and asking a question at appropriate times. We are going to exhibit professional behavior today, and we're going to be like a proton and stay positive. So with that, I am going to stop sharing my screen and let Kathy take over. Kathy?
Okay, I can share my screen now. And sorry, I have to go back. I'm not in the right place. So, hello everybody. It's Friday, and I know so many of you have put in a long week already, so I really appreciate you're here. You can hear that. So today, as Scott said, we're going to start and we're going to think about phenomena. We have had an amazing lineup of people here thinking about phenomena, and each one of them has been different. And this one will be a little bit different too. I want it to be an interactive session. I want to tell you a little bit about how I conceived the idea. So I've always been about phenomena and using it as a routine, but I wanted to really begin to think about how it could be used at home with families. And when we get to the end, you'll see how all of this pulls together. But I just wanted to give you the beginning of this, because I've really been thinking about how can we make science work for our students and children now with their families. So there, and then this is who I am, a little bit of everybody. Mom, a grandmother. I love working. I was a classroom teacher. I was a state science supervisor for years. And now I volunteer in class. I just have a good time doing science. I'm pretty much a science geek, even at my age, and I just keep right on going. So that's that. So to start with, I want you to think about what is a phenomenon. And I'm going to ask you to jot your ideas down, and I'm going to use this handy dandy little timer that I found. And you have about 2 minutes to jot your thinking about what is a phenomenon down. For anybody just coming in, we're just jotting down what we think a phenomena is.
Do you want that in the chat or just on our own paper?
I think we're going to share some of them in the chat. But hold off on that for just a minute, okay? And I have to tell you, these times were just guesswork at how long things would take. So we'll see how this goes this time and make adjustments as we need it. So for those of you who are ready and want to, why don't you share a few of them in the chat, and maybe Scott can read some of them aloud as we're sitting here.
Natural occurrences that spark wonder in students. Observed event to make sense of. Something that makes you wonder. An observable event that occurs in the universe that we can use our science knowledge to explain. Relevant to student experience, although sometimes they can be events or processes that are awe-inspiring or not so common.
Oh, I love awe-inspiring.
Catalyst for questioning, occurrence that promotes questioning.
You are all so smart. When I think about phenomena and the definition that has been given to us by people a lot smarter than me who work together to really put this all together, that basically you all nailed it. Phenomena are observable events that happen and that we use to help us learn more. And by learning more from that phenomena, then we can explain it, and we can sometimes even use it to predict what's going to happen next. So why do we use phenomena? So I think the big shift is, that it's less learning about and more figuring out. Using phenomena, when we begin with phenomena, we can have some amazing science conversations with our students. When we choose phenomena, we really work at making them meaningful for kids. We want them to engage with them. We want them to be curious and intrigued. When I think about phenomena and I try to find a phenomena that works, I also want to think about being inclusive and thinking about what my students already are bringing to the table and thinking about how that can be leveraged by using phenomena. Inviting student questions, and again, just providing multiple opportunities for students to engage and to learn. So phenomena should be meaningful, and I went looking specifically for Nebraska events for this piece because it's the Nebraska Science Teachers Association. So up in the top is obviously the migration of the sandhill cranes. And I am so intrigued by that. I'm going to have to do some of my own research. We have the photo of the sandhills, the chalk mine, the wolf oak tree, which I just want to climb. That's what I want to do. I just want to climb that tree. So the goal is to have it be meaningful to our students so that they really want to participate in the science. And again, the big piece for me, again, is this phenomena doesn't have to be phenomenal. Sometimes it is, but it doesn't need to be all the time. It can be as simple as watching that sandhill crane migration and trying to figure out, when does it happen? Why does it happen? And I've been thinking a lot about wave patterns in wheat since I wrote that down. And I got a little help from a friend on that one. I've been thinking about how I would connect that with sound and light, you know, and thinking about those patterns and how it's similar and how it's different. And just, you know, noticing that puddle, and one day it's there and the next day it's gone. What's going on? So again, it doesn't have to be phenomenal, and it can be from just anything, close, away, just intriguing and puzzling. So I've put together a list of phenomena actually, but I want you to look at this list and decide which one you want to engage with today. And if you have one of your own right near you, that's fine too. But I was really trying to think about something that we could all do in common. And the ones, you know, we can do rubbing our hands together, shuffling feet, a broken kitchen tool, thinking about that. I've been kind of partial to the last bullet myself, watching birds at the feeder, who eats what. But anyway, I want you to choose one of these phenomena that we're going to work with as we go through today. Because from here on in, the process becomes interactive and engaging. So can you give me a thumbs up when people think they have chosen which one they're going to use and think about? I've seen a couple of thumbs. Can't see all of the people, so I'm probably not seeing. Okay, I'm going to assume you've all figured out something that you want to use. All right. What I'd like you to do right now is I want you to really look closely and explore the phenomena you chose. Name the phenomena and record your notice and wonderings. I've given us 4 minutes for that, and I'm going to start my handy dandy little timer here. And I'm going to do it too. Oops. Oops, oops, oops. I think I messed up my timer. So if people are ready, can somebody just, actually we can do this in the chat, or we can do it with a few people. I don't know what it's like, people just sharing aloud what they chose and something they noticed or wondered about. So either way will work, I think.
I'll just talk. I noticed that I was holding my hot coffee cup, and the coffee is warm, which warms the cup, which warms my hand.
Chose the same phenomena I did.
Oh, and I'm sorry. I could wonder how that happens. How does it go from the coffee all the way to my hand?
I don't know what I'm doing. I've lost my Zoom controls here, Scott. Don't know how I've managed that. I can see everybody at the top, but anyway. Well, thank you for participating, all of you, and feel free to put things in the chat. And some of you may have already seen the next slide because I've accidentally gone ahead. But the next thing we're going to do is you're going to actually draw a model using pictures, words, symbols, etc., to show what you think is happening and why you think it's happening. And I'd really like people to work on this one because I want to try out something new as soon as you do afterwards. I'll start the timer. I don't know, I set it for 10 minutes, but just let's take whatever time is necessary. I saw that. You're pretty quick. I apologize for my technicalities here. I'm not sure why I can't access. I can't see. I can see people, but I can't see the chat or any of the things at the bottom for some reason.
Just so you know, Kathy, I started a stopwatch here. We're about a minute and a half in.
Okay. Scott, I'm thinking it's probably not going to take us as long as I thought. So,
It's fine. Just wanted to let you know.
okay. Yes, especially that one. That one's all ready to go. I see one. I'm wondering if we could get an indication of where people are in their modeling. Do they need, how much more time do people think they need?
We're seeing done. Maybe one more minute. Good here. So maybe if you give about another minute, we can move on.
Okay.
I think we're probably good now.
Okay. Thank you, everybody. And I appreciate everybody really trying to participate here. So this next one, what I'd like you to do is if you could take a photo of your model or scan your model and then choose one of these two places, which I believe Scott's going to put the links in the chat to upload your model. And I'm going to try it too, because I just want to see how this works.
The links are in the chat.
And I'm just going to go to one of the two places. Let's see. Oh, mine's a little big. Yay! The reason I wanted to do this is I wanted to show that there's a way that in this remote setting that we're all in, that we can look at each other's models and think about them. Because our phenomena are all different, finding, comparing will be a little interesting. But I do think that if kids had even their own different phenomena all over the place, whether it's, and then look at it and see, so what's similar? Well, I'm going to wait because I'm going to go get ahead of myself, but I am very excited to see the models coming in on the shared models. I have to go look at the Padlet and see what that one looks like. But let me get back to my slides. Oh, and look at the Padlet too. Very nice. So I want to take a minute before I move on to the next, sorry, I'm making a mess here. The next slide, to talk about the process and what people think worked here. Will this work with kids? I'm trying this new for the first time, so I'm just trying to get a handle on whether it's manageable to do with students remotely. Thoughts? Michelle, I'm going to put you on the spot. What do you think? You're muted.
I love Padlet as a way to get students involved virtually and in the moment be able to capture their thinking. And I'm not that familiar with it, but it also looks like you may be able to like make revisions and things so they can add to their thinking and change it based on the discussion.
Any other thoughts? Did it work? Can you see using this?
You know, I think I can see using this just in a regular classroom too, where I teach at the secondary level. My kids all have a phone, they draw things, and it's so easy to just have them draw and share out rather than having to redraw it for the class, you know, from their notebook.
Mm-hmm.
I also, Kathy, you mentioned earlier about thinking about making activities more inclusive. I think this is a great way to do that because it's a low stress situation for someone to be able to share their thoughts without maybe having to make a presentation.
Okay, now I'm gonna go back. Okay, so I really, like I said, this is new for me, and it was a way of thinking about remote learning and how we could do modeling that was meaningful for kids. I'm thinking at the elementary level, kids could have parents in the current situations. Parents could work with them, and I also know that's a little bit stressful because I know so many parents are struggling with being teachers and doing their own jobs at home or whatever that looks like. But I just wanted to share this possibility of doing something like that. So the next slide, actually, I'd like people to actually go on this slide, the chat. I believe Scott put the link in the chat, and think about some of the things that you think were alike and different about those models that you saw. I'm seeing lots of it in the chat, which is fine. Thank you. Yeah, the pictures with labels. Okay. I'm not going to spend a lot more time here. Thank you for sharing some of those similarities. I totally appreciate it. So I'm not going to do this, but I wondered about if there was a way to do a consensus model, thinking about remote learning and students in classrooms. How might this happen? So please put any ideas for this in the chat, and then we can just talk about them for a minute or two. Because consensus models was when I was thinking about this process, I'll be honest, this was the piece I was struggling with the most when I was thinking about remotely. When I was thinking about it happening at home, it could just happen between siblings or family members. They could actually have done two separate models of the same phenomena and then be talking about them and maybe come up with one model. Any ideas for this current situation and this remote learning? Breakout room, yeah. A whiteboard function. Oh, Zoom has one. I didn't even know that. So that's interesting. Oh, yes, you could build a list and then decide how to draw that consensus model. I agree with that too. All right, well, thank you. So the next piece is really looking at and thinking about where else might you have seen that phenomena? When you think about your coffee cup or you think about that cloud formation, is that the only time you've ever seen that cloud formation? Or have you seen it in other times? I was thinking about, you know, the coffee cup and the heat moving from the coffee cup to my hand, the warmth, and thinking about, but the handle was so much cooler. And I was thinking about the pots and pans on a stove and a handle and how the pot is, or the pan is very hot, but the handle, depending on what it's made of, is not necessarily hot. That transfer doesn't happen. So where else might people have seen some of the phenomena they chose? Either write it in the chat or just speak out, please. Oh. No ideas? Oh, here, boiling water, yeah. Tea kettle, mist cloud. Feeding ducks. Oh, you must have done the music one on you. She's doing well, right? Yeah, what would be the differences? You know, I see trees, I see birds at my feet, or I see birds as I go on the walk. Are they the same birds? All of those things would be begin to be my questions. So as we move on, the next part is actually getting us to thinking about what questions would we have about the phenomena you chose. And for this process, it's obviously what it is an adaptation of the QFT process, the question formulation technique, which you can find at rightquestion.org. And it's also, I've also taken into account some work that a middle school science teacher in Connecticut has done, and thinking about her work. But this first piece is really one of the most important pieces. And in that, to get the best questions, you really do have to spend the complete amount of time you decide on to write questions. So what I want you to do is to really, and I don't know if we'll do a full 5 minutes, we may do more like 3 minutes, is really literally just write questions that you have about your phenomena. No statements and only questions. And we're going to write for the full, I'm going to decide 3 minutes, no 5, forget 5, it's too long for this group, working with a group right now. So please, let's write our questions. And we're not going to share these questions immediately, but what you will need to do is to have them to use for the rest of this activity. So please do write down your questions.
That's 3 minutes.
Okay, we're going to move on. And we're not going to do this right now. But what I might have done if I was in the classroom or even remotely with students at this point was I might have them begin to share their question and begin to build this driving question board. This is another site. This is pinup.com, and I had never used it previously to playing around with it for this presentation. And I really do like it. I haven't done much with it, but you can easily, oh, that didn't work. But if you clicked, because that's a picture, if you click on that little plus sign, you can actually put up a sticky note, just like Padlet. And there's some other options there. You can upload things. Anyway, there was a lot to explore in this pinup.com. So I think it's another tool that will be valuable as people are trying to figure out how to work with our students remotely. So I just wanted to share this. So anyway, at this point, if I was in the classroom or remotely, I would be asking students to begin to share their questions. And I'm playing with this idea. Do I want to do this now, or do I want to do it after the next few things we're going to do? So what we're going to do next is we're actually going to begin to look at those questions that you have. And the first thing you're going to do with them is you're going to put a check mark next to any observation questions. Observation questions are obviously questions that you can answer using your senses of seeing, smelling, touching, and hearing. But we don't taste in science, so we don't use that sense. But so when you think about the questions you wrote, do you have any observation questions? And if you do, just put a check next to that question. Maybe somebody can share an observation question if you wrote one, and just speak out loud. I think it's just as easy with our group, unless you're more comfortable typing in the chat.
I'm not sure if this is, how do the birds interact at the feeder? Is that an observation question?
I would think so, because you're looking outside and you're watching them. Any others?
Any others? What time of day do the birds eat?
Okay, because you notice.
I asked if the phone got hot, like if the temperature changed when it was receiving music streaming.
I had clouds, and I asked a couple questions. Are clouds wet? And my other question was, why are clouds different colors? And I thought you could see and feel those.
I asked if there are coffee cups that do not allow the heat to go from inside where the coffee is to the can.
I like that question. I like a lot of questions. I like questions. Okay, we're going to move on. And now I want you to do this. I want you to put a $ next to any investigable questions you have. So an investigable question are questions where you need to figure things out. It's a question where something gets changed. The variable gets changed. So when I was thinking about elementary kids, I was thinking about playing with toy cars and, you know, how far will the car travel on the rug when I push with a small amount of force? And What's the difference when I pushed with a big amount of force? Those are investigable questions. So I want you now to look at your list and see what your investigable questions are, and make sure you use that $sign. When people are ready, we can hear some investigable questions. You can either share out loud or we can put them in the chat.
So I had the rubbing the hands and the rubbing the feet. And the question I had is what other things would cause static? Because I remember when I rub my feet on the floor, I get static electricity. So I was wondering what other things would cause static when you rub them.
I was wondering if birds will eat other types of food that might be placed in the feeder besides just seeds.
I wondered if all liquids in my coffee cup would transfer the same amount of heat to my hand. And all of these kinds of questions that we're just talking about now, we really could investigate. We could begin to figure out to figure out how we could do it. So the last piece what I want to do with the question, and then we're going to talk a little bit about it, is I want you to think about your $sign questions. And those were your questions that you could investigate. Which one of those questions, assuming you have just the opportunity to investigate just one of those $sign questions, which one of those might you choose? And put a hashtag next to that one. And I want you to think about this too when you're thinking about this one. Let's think about our students at home, and we're hoping to inspire them with some of these questions that they've developed about their own phenomena. But we also have to remember that they have limited resources at home. They only have what they have, what's around or what's at the house or what's outside in the yard, especially if they're trying to social distance. And we really obviously don't want to encourage anything different. So when you put your hashtag next to your question sign for this one, think about investigating something about your phenomena that you can do with the resources you have easily available to you. And then I'd love to hear some of those hashtag questions. Okay, I'm ready for some hashtag questions. I got mine. So what my hashtag question was, my first phenomena was the cup of coffee. So my hashtag question was, will all containers that I have in my cupboard transfer the same amount of heat or move the same amount of heat from the container to my hand with a hot, with a hot liquid inside? So does the container itself make a difference? And I was thinking about, I have some plastic cups, obviously, and all the different types of cups I've got. And then also thinking about bowls even, is it still the same? So that was my hashtag question. Oh, sorry. Don't know what happened. I'll stop share for just a second and find I don't know where my PowerPoint went. Oh, there it is. Now I just need to. Sorry, people. I apologize. Now I can't find my Zoom settings. Oh, something wrong. Hit the wrong button. Ugh. So did anybody have any hashtag questions at all now that I've gotten some of those figured out? And if people don't understand what I meant, that's okay to ask that question too. What I was thinking of to help people along was, what's your priority question? What question would you really try to investigate at home? Because you might have a list of 4 or 5 questions, investigable questions, but some of them you might not be interested in really. And some of them you might not have the materials or the resources to do. So you really have to just think about what things you have and what things are engaging you. So what things would engage students? And so that's kind of what I was really thinking about there. So as any of you can see that know the QFT, this definitely is a different way of doing things than they actually do. The QFT actually starts with, after they've listed all the questions, then they do open and close questions and changing open questions to closed questions and back and forth. But one of the things I discovered doing this with both second graders and 4th graders is that I tried that once, and that didn't really work because it would have taken a lot more about teaching about the questioning process rather than the science. And I had limited time. So I wanted to make sure that students had a time to do the questions, but actually did something meaningful with those questions. So I ended up, and I didn't include it in this one, But with young children, my first categorization would have been, which of your questions are science or not? Because many of young children would have questions that might not have anything to do with investigating or the actual phenomena you were talking about. So you had to figure out and put those aside before you could move on. And then I did do testable and non-testable questions, observation questions, to help kids realize the difference between those questions. So that's one of the things that I was able to do and have done. So I want to take a few minutes now, and I'd really like some conversation about what you think about the process for this. And then I'm going to share a tool that will make this whole process easier. But what are people thinking after going through this process? You see it as doable with children. And how many of you I may be talking to the choir. People may be already doing a lot of this too. So I'm very interested. So please, can we have a conversation now? What might you do next?
I just wanted to throw out there is that I think I really like the way that you've streamlined this process, talking about the science questions, testable observation, the dollar signs and the hashtags, instead of getting so caught up in that questioning process. I think this is a great sequence of steps.
Thank you. I will shout out to Nicole Bolduck for that one. I'm going to move on, and I'm going to show you the tool next, and where this idea, tell you a little bit more about where this idea came from and what's going to come from this. So if we go to the next slide, and I think Scott's going to put the link in the chat. But one of the things that's going to be released soon is this template that is called Phenomena for Families. And it was developed mainly, like I said, with people from CS Cubed and Cella and others, basically to really help have a tool or an organizer that families could use at home. So I'm going to walk you through it a little bit. So the beginning is really, what's the phenomena? And they choose the phenomena, and they have a place to put it in this box, in this graphic organizer. So the first thing is that you're exploring the phenomena, so you're naming it, you're noticing and wondering. The next piece is really what's happening with your phenomena. And, this is where the modeling comes in. One of the things that I didn't have originally, and I didn't talk about there, was the key box, but getting some feedback from other teachers who have been doing some of this is that it helped to have a key, for students to actually have a key, so that they could identify what was going on in their model. And then here's the same thing we just went through. What is alike and what's different? And when I wrote this, developed this, it was really because I'm thinking about it at home with families. And I was thinking about it as a low-tech tool that if we could somehow get to families. So I'm asking families to do models together and to look at phenomena together, and then maybe share your model with your family and think about, how is your model different from your grandfather's or your brother's? What parts of the model are the same? So really getting kids to think about and interact too. So the other piece that's happening, if you think about this, is that when they have to compare these models, you're beginning to have a lot of science talk. And granted, it can be informal science talk that's happening at home, but that's okay too. I mean, I always talk about just-in-time language anyway, or just-in-time vocabulary. So the next part is, I would ask, this is the consensus model, the piece we didn't do. As a family, make the model that includes the thinking of everybody. You've talked together, you've worked together, come together and come up with one model that really you think is working and works for you and works for your family. The everyday phenomena. Where have I seen something that's like what I'm doing, the phenomena I'm exploring? And then getting into what questions I have, which is what we just did there. And at the bottom, I've got the check next to your observations and the dollar next to investigation. And that's the end of the graphic organizer. Because when I created it and thinking about it going home to children and families, and it might be submitted back to, I'm gonna stop share on this and go back to, try to go back to my, I didn't mean to totally stop share, but I'll go back to my slide presentation in a moment. I really wanted it to be accessible and usable as a low-tech tool. And I wanted them to be able to use this graphic organizer and not necessarily go in as far as the investigation. They would have just gotten as far as maybe, you know, prioritizing and deciding which question, if they could, which question would they investigate? And they'd probably be able to tell you why. I'm gonna go, actually, I'm gonna start my share again because I want to go back to my slides. And share another tool. So Council of State Science supervisors work together with people from NCEL and just people who wanted to help. And they came up with this new STEM teaching tool that is called Supporting Students During Science Learning During COVID-19. And there's lots of things. And the best part about this is, look at all the languages this document has been translated in. And I'm going to show it to you in English, obviously. And I'm going to go to the sample learning menu, but it's all in all the different languages. And so here is just a tool that's a learning menu strategy, which I think is happening a lot anywhere. Teachers are using this. But basically, it's again giving ideas. So there's some discuss ideas about why it might be harder to see at night or in a dark room compared to daylight or a brightly lit room, versus going up as far as there's other. I want to show that there's things for middle and for high school here too. You know, what makes news fake or real, et cetera, and it really takes you through thinking about that. Here's that coffee container idea. So I just wanted to share the tool and this is that's who I am. It's there. Thank you for inviting me to be part of this lineup. I've had a great time, but I'm willing to talk about anything people have to talk about or would like to know, or thoughts, comments at this point. So I'm going to stop my share.
I just want to tell you thank you so much. This was really helpful. Sometimes going to these things, it's kind of like not super helpful, but yours was. So thank you so much.
Thank you. Do people think that the tools will be helpful? Can you see yourself using them? That graphic organizer?
Yes, I can totally see how to use it. How would we get access to it?
So I think the link is there. It's definitely in the PowerPoint, which Scott's going to share. It's also going to come out, and I'm going to share this with Scott later, is that there's another, the STEM teaching tool was the first project that came out from the group work to support science learning. There's a project that's coming out, I hope by Monday, that's called Project 2, and it's called Reimagining the Possibilities. And this graphic organizer is one of the 3 pieces of that. There's actually, it's called Phenomena Protocol, not just for the classroom. And it's coming out hopefully Monday. And there's also another tool called Pass the Science Please, which is all about science talk and talking at home with families. And there's also a piece that's on science notebooks that I think will be very helpful for teachers. And that project should be up by Monday. And I will definitely I will share it with Scott as soon as I get it so that you have it.
And to answer the other question, all of the resources from this week, all the videos, all the slides, all the other documents, we have posted on our website, which is neacadSci.org/NATS, or you just search for the Nebraska Academy of Teachers of Science, Association of Teachers of Science. And all that information is there. I've posted it in the chat a couple times. I'll post it one more time for you guys. But you know, all of our guest speakers this week have been phenomenal at sharing all of these resources.
So there's a question, there's one question here from Steve. What resources would you recommend for storylining basics, setting up a sequence, etc.? Oh my goodness, there's so many. Well, for middle and high school, there's lots of things that, not lots, but I have things that I would definitely recommend. To start with, Next Gen Storylines is for K-12, and it really takes you through the process. Any of you who attended yesterday saw Abe talking about the process of storylining, using the questions to build storylines. What I would do if it was me in this situation, I have all my students' questions. I've categorized them. I already know, or I've anticipated what their questions are going to be. So I've really thought out what might the first lesson end up being based on what my phenomena is and what I've anticipated for students' questions. So, I mean, I've started with my standard. I've thought about that. I've thought about the phenomena. I purposely found that phenomena so that I could build a storyline of student learning and sequencing. So I'm thinking about, for my own self, Next Gen Storyline is probably one of the best. There's also some good resources from Open SciEd, obviously. Ambitious Science Teacher, which is one of my favorite books, has a lot on good storylining. You know, it's really interesting because nobody has done any of this work at the elementary level right yet. And I'm hollering loud about that happening. So, I mean, excuse me, I would need to rephrase that because Next Gen Storyline is doing it and they have some excellent ones. Yeah. Steve, I don't know if I answered your question. I went round in circles, but.
And Kathy, I'm going to jump in real quick. The Ambitious Science Teaching, Mark Winshittle is going to be our keynote speaker at our conference in late September.
And Lori asked the question, what website went to with the list of STEM activities at home. That came out of the tool, the link supporting student science learning at home. It's on the last slide, and it's a STEM teaching tool, and was just recently put out, and that's where that came from. I want to make sure I've answered any questions. I guess I have. So I'm good if you're good.
I just want to quick tell Scott King, thank you for organizing this whole week and putting all of our resources on the internet. And I can never remember our web address. And so I was just gonna quick, I just typically go to Google and I just search NATS Nebraska and it will pop right up on our web. The first link is always our website, and it's just all so nicely laid out there. Scott has it so organized, and I just wanted to give a shout out to him too. And thank you, Kathy, again. That was amazing.
Well, thank you. And thank everybody. So.